Hi friends, welcome to our new session. Can you read an English story or a novel without knowing English language? No, it is not possible. In the same way, mathematics is the language of physics. So, knowledge of some mathematics is important and essential for studying physics. So, before continuing with our sessions in physics, we are going to study some essential mathematics which is required to study class 11th and 12th physics. We will cover the essential mathematics in some videos. So today we are going to study about two types of physical quantities. They are scalars and vectors. What is a scalar? To understand about it, let me take a pencil. What is the length of this pencil? It is about 15 centimeter. That is sure. There is no doubt about it. That is, the length of this pencil is described completely by a numerical value of 15 along with a unit, that is centimeter. So, we don't require any additional information to describe the length of this pencil. This type of quantities, that is, a quantity which required only its magnitude to describe it completely. We call it as scalars. So, what are scalars? Scalars are that physical quantity which required only magnitude to describe it completely. So, we studied about one type of physical quantity, it is scalars, and the second type we are going to study here is vectors. Let me say an example. What is the distance from your home to your school? Some may say it is 5 km. If you are just saying 5 km, is it completely described? No, it is not completely described. That it is 5 km away from your home, it is correct, but it is not described completely because we need to specify the direction also. If you are not specifying the direction here, that is not completely described. Such type of quantities which require both magnitude and direction to describe it completely are called vectors. So, vectors require both magnitude and direction. For understanding more about its properties, we are going to take two pencils. One is yellow pencil and the other is a brown pencil. The color doesn't matter anything here. The yellow pencil is 15 centimeter and the brown pencil is of 12 centimeter. What is the total length of these two pencils? We know it is 15 plus 12, it is 27. What is the difference between the length of these two pencils? It is this much, and that is 15 minus 12, it is 3. It is very clear. There is no other information needed to describe or do these calculations. That is, we can do it straight as that we do it for ordinary numbers. These are scalar quantities. We already discussed it. The length of a pencil is scalar. So, the mathematical operations of this can be done as simply as we do it for ordinary numbers. So, one property of scalars we studied here is that the mathematical operations are performed as same as ordinary numbers. That is simply 15 centimeter plus 12 centimeter is equal to 27 centimeter if this is the length of pencils. So, we studied one property of scalars, that is, its mathematical operations can perform as same as ordinary numbers. We already studied about scalars in our previous classes. Some other examples are distance, speed, etc. We already studied this in our previous classes. And what about vectors? Vectors are having both magnitude and direction. Examples of vectors we know: displacement, velocity, etc. Now the question is whether we can perform the mathematical operations like addition, subtraction, multiplication, division are same as ordinary numbers in vectors also? No, it is not possible. For understanding more about it, let me draw a figure here. This is your school and this is your home. Now, going to your school, you have to move a distance here in this direction, and that may be 3 km, and after that you turn north and move in this direction, that is 2 km. So the total is 5 km you have to move, but you are now only this much distance away from your home. So the direction is important. So if we add 3 plus 2, it is not equal to this. So we cannot add vectors as same as the ordinary numbers. It requires other methods to add vectors, and we will study it in other sessions. So what we studied? We studied that it requires vector rules to perform mathematical operations. Now, how to represent a vector? To represent a vector, we are putting an arrow sign above it. So, A with an arrow sign above it shows that A is a vector. If I write AB with an arrow sign above it, it is also a vector. So, we can represent a vector by putting an arrow sign above it. In printed books, you can see a vector is represented mostly with the bold letters. So, in printed books or websites, you can see vector is represented with the bold letters. So, that is the way a vector is represented. Let me say one more thing before I close this part. That is there any meaning if I write 15 centimeter plus 5 kilogram? It looks meaningless. So, we can add or subtract values representing same physical quantities, not two physical quantities. So, we cannot add values of two physical quantities, but instead we can add or subtract values representing same physical quantities. That is, we cannot add or subtract values representing different physical quantities, but can only add or subtract values representing same physical quantities. But what about multiplication and division? That we can do it with the different physical quantities. So I studied here two types of physical quantities. One is scalars and the other is vectors. We know in scalars it is only having magnitude to describe it completely. All mathematical operations can be performed as same as ordinary numbers. It can add or subtract values representing same physical quantities. But multiplication division, we can perform it with the different physical quantities. For a vector, it requires both magnitude and direction to represent it completely, and it requires vector rules to perform mathematical operations. Now, we are going to study some types of vectors. First type of vector here we are going to study is equal vectors. When a vector is said to be equal, that is, if a vector A is said to be equal with a vector B, if and only if both magnitude and direction are same. That is, if we can say a vector A is equal to a vector B, if and only if magnitude and direction of both vectors, that is vector A and vector B, are same. Now, the second vector, that is a free vector. Free vectors are vectors does not have any fixed location. That is, displacing such vectors parallel to itself leaves the vector unchanged. For an example, if we are having a vector like this, and if it is a free vector, and if I draw it here like this, it is same. That is, if I displace it parallel to itself, it leaves the vector unchanged. That is, there is no difference between this and this if that vector is a free vector. So, what is a free vector? A free vector does not have any fixed location. We can displace it parallel to itself. Now, the third one we are going to study here is a localized vector. What is a localized vector? It is just the opposite of a free vector. That is, location or line of application is important. So, we cannot displace the vector like this. If we displace the vector, that is a localized vector like this, it is not the same vector because the location or line of application of localized vectors are important. Another type of vector here we are going to study is a zero vector. What is a zero vector? Let's consider a person travels 1 kilometer north and after that he returns 1 kilometer back to the south. What is the difference between the initial and final positions? It is 0. Such type of vector, that is, if its initial and final positions are same, and that type of vectors we call it is zero vector. In other words, we can say that its magnitude is 0. So, in our example, we can say that the displacement is 0. That is, the magnitude of displacement is 0. We will study more about it in later sessions. Now, the last type we are going to study here is a unit vector. A unit vector is simply means that a vector with a magnitude 1. That is, it is used to specify a direction only. And this unit vector is represented with a cap above the vector. That is, if we put a cap above A, then it is A cap. It is the representation of unit vector A. This means that this vector A is having a magnitude 1 in a specific direction. How we can get a magnitude equal to 1? That we can get by dividing a vector with its magnitude. So, if a vector A is having a magnitude A, then its unit vector A cap is equal to vector A divided by its magnitude. Or in other way, I can write it as a vector A is equal to its magnitude into a unit vector in that direction. So, we can represent a vector like this. So, in this video, we studied two types of physical quantities. They are scalars and vectors. Also, we studied some types of vectors. In coming sessions, we will study more about vectors and its mathematical operations using vector rules. Study notes for our videos are available in our website u2belearning.com. So stay tuned with us, keep learning.